First, I drew out the transom on the better face of the sheet of half-inch ply. I used a speed square to draw a line half an inch from the edge to measure from. This will allow me to cut the transom at the angle of the bevel. Then I draw out the transom to the measurements given. These lines are the aft edge of the ply, so the good face of the ply is outside the hole instead of facing inside. Because of the bevel, the inside is slightly bigger, hence the extra wood around the perimeter. I used a string to draw the arc of the transom, but this was a mistake. I should have just cut it proud and then nailed the batten. The end product will be fine, but this method is not as good. With the transom drawn out, I set up my clamped on skill saw track to cut straight lines. The saw set at an angle of 17 degrees on the side and 6 degrees on the bottom. Careful to flare outwards on all three edges. The arc along the top of the transom cut at no angle set on the saw. I cut it proud. I'm planning to trim it down to the line later with a plane. You could cut 1 inch by 1.5 inch cleats for the transom on a table saw. Set it at 17 degrees for the sides and 6 degrees for the sole, but that would be the easy way. I cut cleats to about the lengths of the bottom and sides of the transom and then used a bevel gauge and a hand plane. Either way, your bevel should line up when you glue your cleats to the inferior side of the transom sheet. I use Type on 3 because it's fast and my joints don't have the flaws that my hands would make to create gaps. Once the glue dries, the clamps come off and the transom goes onto the strong back. Next, I prepped the stem out of the best piece of Doug fir that I could find, which was the 2x6x16 that I was ripping pieces from the frame off of. A 2x6x16 is now an 1.5 inch by 2.5 inch. I cut 28 inches off the end because I wanted my stem to be proud about the gunnels. I'll see if it'll replace some of the functions of the bow eye. Also, if I end up putting a mizzen mast in, the proud stem will be a place to attach a bowsprit. And I'll have the option of rigging up a head sail. All this is very much overcomplicating a boat this size, but I want to be able to tinker with different rigs, and also I kind of like that if there's light airs, I can just fly like double the canvas that is normally safe, and so maybe this boat will do that kind of stuff well. Anyways, the stem bevel needs to be carved into this stem piece. I draw a center line along the front edge of the stem. The angle of the sole is 34 degrees or 17 degrees from the center. I drew this on the bottom of the stem. Then 21 inches up from that, the angle is 28 degrees. I use a bevel gauge and a square to find where this point goes on the side face of the stem. This point gets marked on the stem piece. I clamped a steel square to the stem piece to mark a diagonal up the side, and that'll go from the 17 degree mark to the 28 degree mark. That's 21 inches up because the height of the bow is 21 inches. These diagonals need to make a straight plane to the center line of the front of the stem to show a steady changing bevel on the stem for the very front of the panels to attach. I use a plane to remove the excess. It seems like it'll take a long time, but it goes pretty quick, and it's kind of enjoyable to use a plane. If it isn't easy, work on adjusting the tool first. I find that if I'm having a hard time with my hand plane, it's probably less technique than it is adjusting the tool and just like getting the blade set right. I sand down the hide spots to prep for glue. The stem does not need to go on the strong back. My stem was so long to fit with the stations so low to the ground, and I ended up lifting the whole strong back onto bricks to keep the long stem. I didn't realize it until after the panels were going on, so the clip is kind of out of order. Now I'm moving on to making panels for the sides of the boat. I made a pattern by stapling that sheet of paper across my frames on my strong back. Measurements are given in the diagram, but it's comparable in difficulty to just fit it yourself. Even though I had some issues later with stations moving slightly as I attached panels, the fit didn't change any significant amount. An easy mistake is to draw out two planks that are the same instead of mirrored images of each other. You have a problem if they line up with each other lying on top of the other with the same good face of the plywood facing up. That's a problem. You want them to line up, your two panels to line on top of each other and for the edges to line up, and you want to have the two good faces either touching or the two bad faces touching. And that way, when one panel goes on the port side and one panel goes on the starboard side, the good faces can face outside. I swept to my working surface to keep from marring up my material as I carefully line up ends of the ply and make marks across the joints so that I could realign the pieces after they're cut up. Using that paper pattern, I just used a nail to make little indentations into the ply at the measured points. And remember, as you lay these out, to give yourself an inch or two on each edge, an inch or two margin when you cut for individual variants. Don't give yourself more than that, maybe an inch and a half up front towards the bow on these, because the bend in the front is going to give you extra trouble if you try to bend the excess material into that cone shape at the bow. I drew this boat to have a plumb bow, which puts a bend up front that does complicate things a little bit. That plumb bow, it makes the water line go all the way the full length of the bow, but you don't have as much volume up front, and it does make this kind of bend a little bit awkward. But for a light weather ship, a light weather boat like this, I think the plumb bow is the right choice. Extra material around the lines, midships and aft, is fine when you're working on drawing these panels because the bends are simple aft and midships on this. You only need excess margins at one end of the panel because you can fit that closely cut end where you don't have a lot of excess, and then the other end where you have a lot of excess can move around. Butt joints are simple, but I still have to be careful about a couple things. First, they're going to get glued up an inch and a half from the bottom of the plank, and this needs to be a careful measurement because they're going to be on the inside of the hole, and there's going to be a chine log running right there that you want that to be that tight fit. And the chine log is going to be an inch and a half tall. Also, it's a good idea to soften up the edges before they get glued in. I use Type on 3 again, using plenty, and then cleaning up the squeeze out, or not doing a good job cleaning up the squeeze out. I should have used more bricks, as these bricks and weight supply less than an ideal amount of clamping pressure. Next, I cut a bevel on the stations so the panels will lie flat. The stations near the stern should have a consistent bevel from top to bottom, especially the last 3 or 4. It should just be that same bevel across that whole side of the station. But as the stations closer to the bow, as you get closer to the bow, the bevel is going to have more variance from the angle at the top of the station, the angle at the top of the frame, and the angle for the bevel at the bottom of the frame. Remember, the bevel variance in the stem was like 11 degrees. So I used 2 battens to show the bevel angles high and low, trying to make a smooth transition with the hand plane cut, and I'm just eyeballing that transition. With that panel glued, and it's had over 24 hours to dry for the Type on to get solid, I start to fit the panels on the frames. There's an issue with that twist in the plank near the bow that could cause a problem, like I mentioned. Think of an ice cream cone, like a waffle cone. A sheet of plywood is like a waffle cone. You can bend a waffle cone into the shape of a cone, like you can bend a piece of plywood into the shape of a cone. It's what most boats do, most plywood boats, is what they do to make the shape of the bow. A sheet of plywood, though, it won't bend into a spherical shape. It won't simultaneously curve around the bow of a boat and curve up from the sole to the gunnel. You can use more planks to make a more spherical shape, but that makes the build more complex, having more planks to fit. And this build is meant to be on the simpler side. You can also torture a sheet of plywood a little bit and try to get a little bit of shape into it, but I mean, that's really testing its limits. And this is already getting its limits tested here. The bow of this boat is near that limit of what this plywood can take. There are a couple ways to work around the problem with bending a sheet of plywood when you get near its limit that it'll bend. Before you even start bending it, consider that a skinny piece will bend better than a wide piece. That goes for both the thickness of the ply and the lateral width. And I cut my front panel with the maximum margins I had to make maximum room for fitment error. And it almost cost me a sheet of plywood that started cracking outside of that margin. Next, to work with bending ply, move slow. I clamped the bow close, I let it rest for a day or two, and then clamped it a little further. And if the ply still won't make a bend, you can soak it. Ply with waterproof glue can be soaked to make it bend easier. I wrapped ply in towels and hosed them off, and then wrapped it in tarps and let it rest overnight, let it soak overnight. But then sometimes you get an issue where the ply cracks as it dries out. You put that wet ply around a curve, and it dries and starts to crack. So I would definitely not glue a wet sheet of ply. The last thing, maybe the most extreme thing you can do, is to make scarf cuts. I can't imagine anybody would have to go that extreme on a bend like this boat has, unless they're trying to bend ply that's way too thick, though. Anyways, even in my dry climate, my wood wasn't too brittle to make that bend in the bow. It was close, though. I started rushing somewhere around this part of the build and made a simple mistake. I should have fit both panels to the station at the same time. I should have fit both to midships and then moved forward one station at a time before having both of them fit on one station before moving to the next. Instead, I fit one panel and then I fit the whole other panel, and it introduced a little twist in the stations. The twist is maybe a little over half an inch forward or backwards from where the station meets the panel, and it's mostly in station 4. The stern half of the panels is easy in comparison, as long as they're lined up right and you haven't run the panels off the frames. After letting the panels rest for a couple days, I was ready for glue. With imperfect joints, some of them that I need to seal to create airtight chambers, I think PL Premium is the right adhesive for this. Epoxy isn't a bad choice either if your conditions and preferences call for it. I don't have a clip of it, but I marked out the joints locations on the panels before I started taking them off for glue. Then I propped the wood panels off the frames and wiped a damp rag on the joints so that PL Premium would cure. With the joints locations penciled on the inside of the panels, I could put the bead of PL in just the right spot on the panel and then twist a proud screw through that panel and through the glue so that it would be able to find the hole in the frame that it was already in. That assured that I would get the exact same fit I had before the glue. I know my joint has a good chance when the PL squeeze out grows as the adhesive expands. I glued the front half working forward from midships, then the back half working back from midships, making sure not to skip that midship station, I forget which one. Here I have a clip of me using that wet rag to help that poly adhesive cure and foam up. 5 screws or so on each frame should do enough for clamping pressure. Some guys don't like making holes with mechanical fasteners, but this isn't a show boat. This is a boat for using. The screw holes will get filled later when you're prepping for finishing. It's like the perfect job for thickened epoxy. I think I saved the stem to glue last. The damp rag and adhesive before creeping in with screws like I did when I was fitting it. I left my panels long and cut them after they were glued, which wasted ply that would have made a good centerboard trunk. The panels are done after 2 days of letting that polyurethane glue cure. Next, it's time for the chine logs and the sole. I cut the bevels on the sole before I put on the side panels, so it makes the timeline of the video off, but they make more sense at this point in the build. Just like making the bevels on the sides, I ran a batten to show the bevel angle and then used a hand plane to cut that angle. I had some wonky cuts in my plywood frames that I had to clean up too. I got a new tool around this time, a spoke shave, which it took some careful adjustment, but once I got it adjusted how I liked it, it became a cool tool. I'm glad I got it. These bevels are at a mellow angle. You don't have to cut a whole lot of wood off, so it's not really clear where you've cut. So mark a pencil all over where you're planning on cutting, and then as you cut, you'll see where you've removed material. Back to the table saw to cut 1.5 by 7/8 inch chine logs. These came from the rest of that 2x6 by 16 that now was like a 2x6 by 13 and 8 inches or something, because it was the last 2 feet plus was used for the stem. I made a 30-degree bevel down from the tall edge on my chine logs. This is not for fitment. The bevel is so that when it's on the inside of the boat, water doesn't pool up inside the chine logs that are glued flush with the panels. A boat with water that flows freely to the lowest point is just easier to clean out. This bevel also just happens to make the chine logs naturally bend to the curve of the chine, with the cutout bevel wanting to be on the inside radius. The angle at the bow should be 17 degrees. Then measure the length of where the chine logs are going to fit and test out the fit. Only the obtuse angle of the chine log needs to get softened, because your other 3 corners are going to be on plywood. I dampened the joints for PL Premium again to glue the chines, because it's going to expand to seal those gaps. You squeeze it out of the tube, you buy it at Walmart, it doesn't melt in the heat like epoxy. Yeah, I like the stuff. The face of the chine log that is facing up is situated on the strong back. It needs to rise up at an angle above the lateral frame pieces, because it's going to get planed down to be flush. So you want to have these chines a little bit proud. I bought a dozen spring clamps for this, in addition to all the clamps I had, and I still used just about every one I had to clamp this glue up with one chine log at a time. Next is to cut the bevel on the chine logs for the sole. A disadvantage of the PL Premium is that it needs more time than wood glue or epoxy. I give it 2 days before I remove clamps. Then I cut off the excess panel to prep to cut the bevel for the sole. The angle for this bevel is easy to find. Just lay something flat across the chines. Here I found another way to my station 4 that had moved. I found another way that it moved, and that I think when it twisted, it got pulled a little bit down towards the ground, towards the strong back. So I had about an 1/8 inch gap I needed to fill, so I cut a shim and glued it in. I went back and recalculated measurements from my drawing and station diagram, and they recalculated to be correct again, so I think that it moved. Or I had it on wrong before the planking and didn't notice, but I think what's most likely is it twisted and got pulled down. Now it's time to make the sole. First, I measured the distance from the back edge of the transom to station 4. The dagger board is going to be aft. It's going to be behind station 4, towards the stern from station 4, and I want to be sure that I have enough room for a butt joint just forward of station 4. I'd prefer not to have a butt joint in the middle of my dagger board case. It's just going to make it harder to fit. Your butt joints, according to Michael Storer, need to be 6 times the thickness of the plywood that they're joining. So my 11/32 inch ply is about 1/3, so I need about 2 inches clearance on each side of the butt joint. I think I've got like 2 3/4 inch clearance, so it is going to be a snug fit. You can make the butt joint work in the middle of the case. It's probably going to make a stronger joint, but it's the fitting the case is just going to be a little bit of a headache. It would be easier to just lay your plywood on the boat and trace your outline than to measure out the sole like I did. You could screw it in place before you trace to cut out the line, and then you could cut right at that line. If I were to do it again, I would cut at the line for the aft section and then leave a little room on the forward section in case things shifted a little bit during glue up. The butt joint strip piece is 4 inches wide, 2 for each side, and it needs to be fitted to the sole piece so it sits right inside the chine logs. And because mine is just forward of station 4, I fit mine to sit flush against the station frame. I just set the aft piece of the sole on the boat and traced where the line sat, making it easy to set the sole panel on the ground and transfer those measurements to the butt joint strip before I glued it up. I traced the station placement before and after my panels were attached, but the video is better from before the panels were on. Type on 3 in clamping pressure and 24 hours for it to dry. Now to attach the sole. With that butt joint carefully placed, the sole fell in place like a puzzle piece. Before glue, it's a good idea to make one well-placed screw through the sole into each lateral station frame. Then you won't have to find it later when the glue is setting up and you're trying to glue that sole down. If you're meticulous, you could pre-drill and set every screw in the sole in advance, because not much is going to be able to move in this. But again, I was rushing, and I made 2 mistakes when I was gluing on this sole. First, I pushed too small a bead out of my tube of PL Premium, and my imperfect joints didn't get as much squeeze out as I would like. Also, I did not have as many screws on hand as I should have had, and I ended up clamping down the sole not as consistently as I would have liked. I did okay, but with more screws on hand, I would be more happy about that joint with the sole. With the glue, again, I worked forward from the middle, just like on the panels, and then from the middle back, and ran a damp rag along joints before using that poly adhesive. Even coming back with a few screws I could scrape up to fill in gaps in clamping pressure that I'd missed along the chine logs, it didn't fill in the clamping pressure I should have. I just needed more area to be clamped down better. I'm glad I went a little overkill on this thing structurally now with too many stations for about this size, with errors like this kind of piling up. Anyways, if you didn't believe I was rushing, I risked the whole build by cutting the excess of the sole off by carefully setting the depth on a skill saw and then just running it along the edge by sight. A pole saw would have been much more appropriate for this. Finally, it is time to roll it over. I'm going to clean up the chines when I finish the kickflip for finishing the outer of the hole, but for now I suspend it and flip it right side up. There's still plenty of work on this boat, but it actually really looks like a boat now. I'm liking the shear line that stays high, almost to midships like a koval, but it needs to get cut down. But I'm really happy with the way this thing looks.